Good morning, ma'am. Today I am going to say about experiment 3 in Advanced Operating System Lab, that is vector logical clock. And coming to this experiment, so the main aim of the experiment is to write a program for vector logical clock. A vector logical clock is mainly based on the transistent dependencies of the recovery. Uh, So, vector clock is an algorithm for generating a partial ordering of event in a distributed systems and detecting causality violations just as in lamp board timestamps. Interprocess messages contain the state of sending process logical clock, and a vector clock of a system of n process is an array or vector of n logical clocks. One clock per process, a local smallest possible values copy of global clock array is kept in each process with the following rules for clock updates. These are the rules, and this is the algorithm for vector clock logical clock. And first we will start the process, and initially all clocks are 0, and then each time a process experiences an internal event, it increments its own logical clock in the vector by 1, and each time for a process to send a message it must increment its own clock and then send a copy of its own vector. Each time a process receives a message, it increments its own logical clock in the vector by 1 and updates each element in its vector by taking the maximum of the value in own vector clock and the value in the vector in the received message for every element. So coming to program, first we use packages, and then we use a class, a public class vector, and then we use a function called input. In that function we initialize the processes and different types of initializations for events and processes, and for timestamps, and these are the initializations and scanner we use. And first we enter the number of processes, and then we enter number of events for each process, and then this is to increment, and this is to increment and do some operations on events for each process. And coming to next, we will enter a number of messages, and for source and for destination we will enter, first we enter number of messages, and for again we will enter messages for source and messages for destination. And this is the logic for source and destination. And here we assign timestamp values, and we will give some uh, events. Every event have clock value as 0. As it increments, the message will pass through other processes. So this is the timestamp of I and j minus 1 of k. This is a vector. For vector, this is the initialization, array initialization, and that is not equal to 0 and equal to 0. Then it will give timestamp of I j k equal to timestamp of I j minus 1 k. This value will assign to this. So it will give how many process we have, how many events we are having, and it will give timestamp values for everything. And coming to this is the main block, public static void main. In Java we use it as main, and for vector v is the object and new vector. we are calling that input function into this main function. So all the computations that are done, that will come under main and that will be executed. So coming to output, first we enter the number of processes, we enter it as 2, and we enter number of events for process 1 and process 2. We give two processes, and for that we are assigning events, and then we are giving how many number of messages, and then we are giving what is the message for source 1 and so message for destination 2, destination 1, source 2, destination 2, and source 3 and destination 3. And it prints like this for process 1 and for process 2. So the program is executed successfully. So in logical vector clock, we use only logical clocks, but here we use vector clocks also. For every event, we will use a vector clock that is initially assigned as 0, and after it is assigning to some other events, it will increment by 1. And here we are showing a pictorial representation as it is casually related how one process is related to another process through events. Uh, so this is about third experiment, that is Vector's logical clock. Thank you.